Hello everyone. On this video we will be looking at an intro to limits. Okay, now it's the one rule that we know is universal no matter what level of math you're in, and that rule is your denominator can never ever equal 0. Okay, so to kind of explain the idea behind limits, first thing we're going to do, let's say if you imagine the sketch for f of x is equal to x to the third power minus 1 all over x minus 1, given that x cannot equal 1. Alright, so we know x can't equal 1 because you have 1 minus 1 is 0, and you can never ever have a denominator of 0. But what a limit does is it says, okay, we know it can never equal 0. But what if it gets really close to 0 on both sides of 1? So that means it gets really close to 0 to the right of 1 and really close to 0 to the left of 1. Alright, so what we're going to do is we're going to go ahead and draw a little table here. Okay, this is your x. And this is your f of x. Okay, so what if right in the middle we put our x equals 1? Okay, so we know x can't equal 1, but we want to find out what value as x gets closer and closer to 1 will that f of x equal. Okay, so basically what we're going to do is, and this is just to give you a visualization, we know x can't equal 1, but we're going to get really close to 1 from the left side and really close to 1 on the right. So this is x approaches 1 from the left, and this is x approaches 1 from the right. Alright, so what we're going to do is we're going to get values closer and closer to that 1 that we can't equal. Okay, we can't equal it, but we can get really close to it. Oh, let me pull this down a little bit. Okay, so let's say if we have x equal from the left, remember, so let's say this would be like a 0, and let's say this would be a 2. So we're going to get closer and closer this way and closer that way. So you don't have to start at 0 if you don't want to. But let's say if we start at 0.75, and then let's say we start, well, 0.75 would be about right here. Let's say we start at 0.9, then 0.99, then 0.999, and you can just keep going and going. Okay, so let's say x is equal to 0.75. And let's say if we make that equal to 0.9. And let's say if we make it equal to 0.99. And let's say we make it equal to 0.999. Now, of course, we can just make it 0.9999. We can keep going and going. But this should kind of help us determine a pattern. Okay, so let's say if we're approaching 1 from the right. Okay, so we could start at 2, then 1.5, then 1.25, but we're not going to go that far. We're going to start at 1.001, which is still just a little bit to the right of 1. Let me clean that 1 up a little bit. 001. Here we go. And what about 1.01? That's a little bit bigger. And 1.1. 1.25. So what we're doing is we're going to 1.25, 1.1, 1.01, 1.001, and you can go 1.000001, 1.0000, and you can keep adding zeros and then put a 1. It'll get closer and closer to 1 without actually equaling 1. Okay, so we're approaching 1 from the right, and we're approaching 1 from the left. Okay, now here, if you want to use a calculator, you can. But if you plug in x equals 0.75, you'll get 2.313. If you plug in x equals 0.9 into that equation, your f of x would be 2.710. If you plug in 0.99, you get 2.970. If you plug in 0.999, you get 2.997. So we kind of get an idea of where we're going. Now let's try it from the right. If you plug in 1.25 into x, you get 3.813. If you plug in 1.1, you get 3.310. If you plug in 1.01, you get 3.030. And if you plug in 1.001, you'll get 3.003. So you kind of see where it's going. So again, if you get 1.00001, 1.000, and if you just keep adding zeros and then the 1 and you're getting closer and closer, you see here that this f of x coming from the left looks like it's going up to 3. And this one coming from the right is going down to 3. Okay, so we kind of have an idea of what we're looking at. All right, so let me go ahead and move that up. So what we're going to do is look at the limit of f of x equals x to the third minus 1 over x minus 1 as x approaches 1. Okay, now that has its own, I guess you could say, terminology, where you have the limit of x to the third minus 1 over x minus 1 as x approaches 1. So that x approaches 1 is just this down here. And judging from this, we can see that that limit is 3. Because as you approach 1 from the left, it's getting closer and closer to 3. As you approach it from the right, it's getting closer and closer to 3. So from the left and the right, both approaching 3, then that limit is 3. So it's equal to 3. Okay. Now, if we look at that in a graph, if you like, you can go ahead and put that in your graphing calculator, your x to the third minus 1 over x minus 1. But if you look at the graph of that, move that up a little bit more, make sure nothing's cut off on the screen. Okay, so it would look something like this. So this is your y-axis and your x-axis. So this is 1, this is 3, and let's say this is your, well, I'll graph it first, and this way it won't be out of place. Okay, so your graph will look something like, kind of clean that up. And word of warning, I do not have the steadiest drawing hand, so you will see quite a bit of erasing going on. Okay, so it will look something like that, but as it gets here, you may bring this up just a little bit more. So it kind of looks like a parabola. Of course, if you put it in your graphing calculator, it would look a whole lot neater. But as it gets closer and closer to our x equals 1 value, as it approaches 1, because this is your 1 value right here at that open portion, when it approaches 1 from the left, it's getting closer and closer to y equals 3, or f of x equals 3. And when it's approaching that value from the right, it's approaching 3 also. Okay, so this is how the graph will look for that particular f of x function. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to the general idea of a limit. All right. All right, let me bring this down just a smidgen. All right, so in general, say if f of x becomes really close to a single number L, as x approaches c, from either side, the limit of f of x as x approaches c is L. Or, in other words, the limit of f of x as x approaches c equals L. All right, so I'm just going to go back to the previous example really quick just to show you how that applies. So you have the limit of f of x equals L as x approaches c. If you look at this one, you have the limit of your f of x as x approaches, well, it should be x approaches c equals L, as x approaches c equals L. In this case, your limit L is equal to 3. So this is your L. So your L would equal 3, your C would equal 1. And this is your f of x, which we already knew from up there, but that's your f of x. Okay, so just to kind of show you how everything kind of pops into place. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. All right, so let's say, for example, we have f of x equals x, excuse me, over square root of x plus 1 minus 1 as x approaches 0. Okay, now the thing is, you might get a problem that words it out just like this. All this means is that the limit of f of x as x approaches c, you would just write it, or you might even see it as just the limit of x over square root of x plus 1 minus 1 as x approaches 0. Okay, so you can see it written out this way, or you can see it just as a simple limit problem right here. Okay, so you want to find the limit. Okay, now what I want you to do is I want you to go ahead and press pause and work this one out on your own and use the previous example as kind of a guide. Alright, so I'm assuming you've pressed pause and you've worked this one out. So we're going to go ahead and verify your answer. Okay, so just like before, I'm going to draw like a little table. We have your x and your f of x. And we're approaching 0, so we're going to put 0 right in the middle. And we don't know what that's going to equal as x approaches 0. Alright, so if you remember, this is just your basic number line. So since 0 is in the middle, we'll put -1 here and 1 here. Move that up a little bit. There we go. Okay, so we're going to approach 0 from the left, and we're going to approach 0 from the right, and they should give you the exact same value that it's getting closer and closer to. Okay, so if we're approaching it from the left, let's say x is equal to -0.01. Now, if you wanted to, you could start at -0.5, then go to -0.1, and you can do that. There's no right and wrong approach. You just want to get closer and closer to 0 from the left. So what you start with isn't that important. It's just that you know that you're getting closer and closer. So your start x values will be a little different than mine, maybe. Okay, so if we're starting at -0.01, we'd be about right there. Then if we go to -0.001, we get a little closer. Then we get a little closer if we have -0.0001. Actually, let me give this one a little more room. There we go. Okay. Now, going from the right, what if we start at +0.01? Then we go to 0.001. Then we go to 0.0001. Again, we're getting closer and closer to 0 from the right and closer to 0 from the left. Okay, so if you plug in -0.01 as your x value, you'll get, oh, I should have made these bigger, 1.001. 99499. You plug in negative 0.001, you will get 1.9995. And if you plug in negative 0.0001, you will get 1.99995. Okay, so as we're getting closer and closer to 0 from the left, we see where this is going. It's kind of getting closer and closer to 2. You got 1.99995, which is really, really close to 2. It's not 2, but it's really close to 2. So now we'll try it from the right. If you plug in 0.01, you get 2.00499. Okay, if you plug in 0.001, you get 2.00050 or 5. You don't have to put the 50. Okay, now if you plug in 0.0001, you will get 2.00005. Okay, so as you can see here, when you plug in those x values that get closer and closer to 0 from the left, you get closer and closer to 2. If you plug in those x values that get closer and closer to 0 from the right, again, you get closer and closer to 2. Okay, so you're getting closer this way and closer this way. Okay, now since both sides appear to be getting closer and closer to 2, we can estimate the limit of x over square root of x plus 1 minus 1 as x approaches 0 is equal to 2. Alright, so if you were to graph that one, it would look something like this. So let's say would go here, and it's going to be an open circle there. So let's say this is 1, and this value here is our 2. Let me clean up that 1 a little bit. Okay, so you can see as this value is getting closer and closer to 0, because remember your y-axis is just x equals 0. As it's getting closer to 0 from the left, it hits 2. And as it's getting closer to 0 from the right, it hits 2. Okay, so now you just have to remember one little rule, is that just because a function is not defined at whatever the c value is, doesn't mean the limit doesn't exist there. The limit exists even if it's undefined. So even though if you plug in x equals 0, you'll get 1 minus 1 in the denominator, which is 0, it's not defined. But just because it's not defined at 0 doesn't mean the limit doesn't exist. Okay, so I'm going to write that down here. It's just a little side note. A limit can exist even if a function is undefined at x equals c. Okay, so even though this is undefined at x equals 0, we still have a limit that exists. Okay, it won't always exist, and we'll get to that a little later in later videos, But even though it's undefined at 0, the limit still exists at 0. Alright? So, now, thing is you have to, one thing you want to remember is that there are plenty of methods for finding the limit that don't require going through these steps. So don't think, okay, I have to go through these each and every time. You only have to go through these steps if that particular problem asks you to. And this is to help you understand the concept. Okay. Now, in future videos, we will uncover methods of finding the limit that are really, really quick and really, direct and to the point. Okay. So just kind of hopefully go over this and it makes a little sense. And I will see you on the next video.